Every large building has this hidden nervous system. It's a super complex web of wires and circuits all buzzing with energy right behind the walls. And it can seem pretty overwhelming, right? But today, we're not just going to look at it. We're going to learn how to decode its blueprint. Let's dive in. So this document right here, this is pretty much the heart of the whole system. And yeah, I know, it looks like a really dense grid of text and numbers. But trust me, this is the map. This tells you exactly where every single bit of power is going and what it's doing. So the big question is, how do you actually read it? How do you take this and turn it into something useful, something you can act on? Well, that is exactly what we are about to break down, step by step. So here's the plan. We're going to start with the key to the code, then we'll learn its grammar. After that, we'll cover the one critical rule you absolutely have to know. We'll trace a real circuit together, and I'll leave you with a handy field guide you can take with you. Okay, so what is this master key to a building's entire electrical system? Well, it all comes down to one essential document. It's called a panel schedule. And yeah, you can think of it like the Rosetta Stone for the building's power, or maybe the ultimate cheat sheet. It's the official record of every single circuit coming out of one electrical panel. When you boil it all down, the panel schedule tells you three key things: what each circuit is for, the size of its breaker, and, this is super important, the panel's total power capacity.
And why should you care? Well, think about it. With this, you can instantly check if what's built matches the drawings. You can spot a panel that's about to be dangerously overloaded, and you can answer questions from subcontractors in seconds, not hours. It's basically a superpower on the job site.
Okay, so we know what it is. Now let's learn how to speak its language. Because once you get the basic grammar down, you'll be able to read any panel schedule you come across. At its core, it's just a simple table. You've got the circuit number, or CKT for short. You've got the load description, which is just a fancy way of saying what this circuit powers, and then the breaker amps, which tells you its size. That's pretty much it. Simple, right? Okay, now here's the first big aha moment. This whole thing isn't random at all. There's a universal logic to it. Inside the actual metal panel box, all the odd-numbered circuits are physically on the left side, and all the even numbers are on the right, always. You just learned the first rule of the code. So we know where the circuits are. Now let's talk about the kind of power they deliver. You're going to see terms like single pole and double pole. A single pole breaker is for your everyday stuff. It takes up one slot in the panel, gives you 120 volts for things like lights and outlets. But a double pole breaker, that's the heavy hitter. It takes up two slots to deliver 240 volts for all the power-hungry equipment like HVAC units. And once you know that, you start seeing these patterns everywhere. If the schedule says office receptacles, you can pretty much bet it's a 20-amp single-pole breaker. But if you see HVAC unit, you know to look for a much bigger, beefier double-pole breaker. See? You're not just reading anymore, you're starting to anticipate. All right, listen up, because this next part is probably the single most important safety check for anyone who isn't an electrical engineer. Here's how you can spot a panel that's in the danger zone without having to do any complicated math. So let's think about a panel's total power capacity in three simple zones. Anything up to 80% full, you're in the green. That's the safe zone. But from 80 to 100%, well, now you're in the caution zone. And anything over that is a serious problem. So the crucial point, the magic number, is this: 80%. If you look at a panel schedule and see the total load is at or above 80%, that is your red flag. You stop and you let an electrical engineer know before anything else gets added to that panel. This one little check can prevent huge failures. Okay, time to connect the map to the real world. Let's take everything we've learned from the panel schedule and actually use it to trace a circuit right on the building's floor plans. It's a really simple three-step process. First, just pick a circuit on the schedule. Second, find that exact same number on the electrical floor plan. You're going to look for something called a home run symbol. It's literally the line on the drawing that shows the wire's path running home to the panel. And third, you just follow that line and see every single outlet, light, or piece of equipment it powers. We've definitely covered a ton of ground, so let's boil it all down into a simple field guide, just the absolute essentials you need to remember. All right, here's your cheat sheet. The panel schedule is your map. Odd circuits are on the left, even circuits are on the right. Single pole is for 120-volt everyday stuff. Double pole is for 240-volt heavy equipment. 80% is your capacity red flag. And finally, always trust but verify. Make sure the labels on the actual panel in the field match what your schedule says. And I really want to leave you with this one last absolutely critical thought.
Just because you see empty spaces in a panel, it does not mean there's spare power. A panel can look half empty but be at 95% of its total electrical capacity. So remember, spare slots do not equal spare capacity.
So there you have it. You now have the tools to read the electrical blueprint of almost any building. The next time you walk through a construction site or even just your own office building, think about that hidden map. What story is it telling you? Is everything organized? Is it being pushed to its limits? The cool thing is now you actually know how to find out.